Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and cagglers about their journey, experience, and talk all things about data science. Welcome to Chai and NLP, CTDS.show. In this episode, I interview Ekaterina Kochmar, who's a lecturer and researcher at Cambridge University and co-founder and the CSO at Korbit.ai. As you might know, I'm a fan of learning to learn the topic in general. We bring back the conversation in this episode. Katrina has been working on automated language teaching and assessment, which is using machine learning or different tools to augment teaching as an intelligent tutor, to build intelligent systems for teaching different concepts for language, specifically English language, and even beyond. For example, teaching machine learning and NLP concepts. We have a deeper dive into this conversation. We really discuss what does building a system like this take, what research goes into it, and what are the interesting trends here. We also dive into Katrina's approach of research and what does a research pipeline for her look like. We briefly discuss our upcoming book titled Getting Started with Natural Language Processing, of which there will be a giveaway of 5 books as well along with this episode. So please find the details to enter in the show notes. I think this was a really interesting conversation around how we as humans should learn and how can we use data and machine learning in general to help us learn better, which is definitely, I think, an important topic in today's times, given all of us are learning online. So now, without further ado, here's the conversation. Please enjoy the show. I am honored to be talking to Katrina Kochmar on the podcast. Katrina, thank you so much for joining me on the show.
Thank you for having me.
So I'm an outsider to research, and I love asking really stupid questions. So I have a lot of them lined up. But first, I'd love to know about your journey into academia. You followed a traditional route, by which I mean completing a bachelor's followed by a master's, then a PhD, and then research. Can you share your journey and at which point did you find your interest for NLP?
Good question. Even though within this definition of the traditional routes, I didn't follow traditional routes as I stayed in academia for quite a long time. I followed my studies with actually staying in academia and becoming a researcher. But in a way, my route wasn't that traditional because originally and from the very beginning, I was very interested in languages and in particular how people acquire languages, how languages work. So I started, the first degree that I did was in applied and mathematical linguistics. So that's where we are trying to identify the structures behind language. So it's not just about any particular language, it's rather that we recognize that there are specific underlying rules in language. It works almost as a precise and mathematically describable system. So we're trying to identify how to explain this, how we understand language, how we learn language, how language develops. So we try to establish those rules behind language. And theoretical linguists work with these assumptions. They're trying to identify this by theories. And in the due course, while I was doing that, I got interested in computational methods. So my master's degree in the University of Tübingen was on computational linguistics. And this is one step closer to NLP. It's quite often even sort of mixed and combined into single fields. But basically what we are trying to do with computational linguistics, we are trying to identify those underlying rules in languages by means of computation and using computers, machines, and so on. Whereas NLP I see more as this technical field that is quite inspired and powered by engineering approaches. So it's more sort of about engineering, but it's also, it works with language as its primary area of interest and research. So that journey brought me closer to working on NLP, and that's when I did my master's and PhD in Cambridge on natural language processing, and my degrees in general in computer science, because that's the domain to which NLP, with which NLP overlaps quite a lot. So, and in the course of doing that, I got very interested in research, and I realized that I want to investigate and really study how things work. So I'm driven by the research-oriented sort of mind and view of the field.
So today, do you see the boundaries blurring, or do you still see a distinction between mathematical linguists and computational linguists? Like you said, NLP is somewhat at the intersection. Do you think the boundaries are blurring now?
I think they probably are, to be honest, because right now NLP is in the spotlight. It's becoming a part of this big move towards introduction of AI into our lives. So it's becoming less distinct. Research, practice, implementation, and AI as the big fields now consumes all the other fields like computer vision, natural language processing. It's all parts of how we can build machines that replicate what humans can do and how humans think and so on. So I still think that there is a value in computational linguistics, mathematical linguistics, because that's where NLP actually takes its inspiration and their ideas about how language really works for humans. There is a bit of a danger that we just delve too much into trying to learn in statistical ways, just from lots of data in the engineering way, and just use these powerful machines to replicate what's been done before. So research in computational linguistics, mathematical linguistics is still very important, because that's where we actually investigate very deeply what language is.
Definitely. And I think your research interests include you mentioned automating parts of the process. You're automating teaching, sort of automating yourself, if I may. Can you share your research interests, and what does automated language teaching and assessment entail?
Yes, so in Cambridge, I'm part of the institute that is automated language teaching and assessment. That's where we investigate how language is acquired by second language speakers. So those are the basically people who don't speak English natively, which is, I would say, the majority of people who speak English and not speaking it natively. So there are different issues, different challenges, different interesting aspects to investigate here. So in this institute, in this research group, we are focusing on various aspects of language acquisition and how we can build educational applications to help with that process. So we've been looking into how to help people write in English better. That is, for instance, when you write something, a text, a letter, whatever, their system will suggest where something goes wrong, but also we'll try to teach you about how language works, how you can develop your writing skills. I have been working on reading skills. Most recently, that's my interest, and this is where we are trying to help people read at the level where they can understand the text. So there have been, it actually is not related to just second language learners. So in particular, the reading skills are quite important for a wide range of different readers. And my sort of favorite example is that in the States, there was this story when they found out that lots of car accidents involving their child seats were related to the fact that people didn't quite understand the technical manuals about how to install those child seats properly. And that resulted in lots of accidents. And if we think about it, if we develop this example, so this is actually not about people who have poor reading skills. Lots of people, even native speakers, have poor reading skills, in fact. And then there are specific types of impairments that prevent people from reading and acquiring this information. And reading is very important because that's one of the primary means of how we get information. But if we think about ourselves, like for instance, if I try to read an article in the fields that I'm not an expert in, that's where I will have trouble understanding lots of things. So that is where reading for me will be challenging. And anyone can put themselves in this position. So many times I read a technical manual and I don't understand certain things, and it might be quite important that I do actually understand them. And the most recent examples include medical information. Right now, in the current situation, we all want to know what's happening, and we want to read about that, and we want to understand the details. But that's where there is this gap in understanding. So, in general, my research is about how we can make information more accessible. So, I have been focusing on second language learners. That is, how we can make text more accessible for people who might not have the language skills at that point yet. So when we start learning language, we're beginners, then we become intermediate speakers, then we become advanced and so on. So the first step is to be able to find the texts that are at this level of understanding. So for example, if I present a beginner in language learning with some literary texts from, say, Shakespeare might be not a good example because it's a very old language. So even good like language speakers won't be able to understand some things. But say some literary work or an article from The Guardian even, or something like that, they might struggle. So the very first step is how to find the right material. Secondly, how do we provide them with the material that will also allow them to develop the skills? So that might be generally at the level of understanding, but maybe just a bit challenging. So that's how people learn vocabulary of the language and learn language further. And then also having a text that we might have found on the internet or somewhere, can we adapt this text to the level of understanding as well? So can we identify what exactly is challenging and can we change it in the text to make it accessible? So that's in a nutshell the research that I've been doing. And within this institute, we've also been looking into speaking and listening, all types of skills that we as human beings employ when we work with language.
That's really fascinating. And me personally, I'd like to think I have okay English skills. But so, for example, I was recently setting up this camera and I was going through the manual, which surprisingly for almost all electronics products are there in every single language, also have photos. And still most of the times we're forced to go to YouTube and check a tutorial somewhere just because maybe they're not clear enough. So I think that's also interesting in different ways.
Yes, and that also sounds like, I think YouTube is a good example of the multimodal information accessibility. That's probably also the future of this research into how we can combine different sources of information to help people understand better. So YouTube is a great example because quite often when we can't understand from the text what's happening, we can also have some visual aid with that by searching on YouTube or any other channels.
And based on how you explain the process, it also looks like different blogs are going on at the same time. For example, understanding the level of the audience, then understanding if the text fits to them, and then also augmenting the text. So how do these fit into the picture?
This last bit, I haven't explored much yet, but I think this is one of these things where we say that AI in general, for instance, includes lots of different modalities. So it's not just about language, it's also about vision. And we, for example, when we access information, we get it through all possible means of and routes. So we read, we listen, we see things and so on. So I think in general, and ideally, the teaching process should be structured about as many possible routes as possible, or as we can include. So that's probably some future plans or some sort of bigger vision that we can combine all these different sources of information. And in general, I think that's probably what will be happening with the educational applications in the future.
Definitely. I think it's especially with machine learning, at least what I found useful is just finding a different article. Sometimes different perspectives are really helpful in understanding concepts. And I think that would extend beyond the field as well in general to different things, I hope.
Yes, exactly. And I think we do see quite good examples recently in machine learning research and in AI, how researchers connect vision to text and, for example, generate captions for the photos or for the videos, or try to explain what's happening in the visual scene, or try to other way around generate the visual scene from the description in the text. So all of these multimodal things are quite interesting, because essentially that's what we do. We have human intelligence. So obviously, to have an artificial intelligence sort of agents, we need to have all these different sources, and they also work simultaneously for us, for example, and therefore that's quite an interesting direction of research, and that's probably how it will develop in the future.
Definitely. Dima Damain, who's earlier on the podcast, she also shared this view where instructional videos on YouTube as a multimodal way for humans and also machine learning or AI models to learn is also a very interesting direction that I think is just being started, is just being explored just now in research. It's just been started.
Yes, exactly. It's quite challenging
For sure.
connecting all these different sources, and it has lots of research questions in itself. But as their ultimate goal, I think it's an important one.
Okay. And I also really love understanding how great researchers approach different problems. So I had read that, and you've been working in this domain for a while. I read that in your master's you had received a distinction for error understanding. If you could share what research for you today looks like, what does the pipeline for you look like? And as a proxy, if we could understand any of your recent works, for example, the one I was going through, which I really enjoyed, was automated personalized feedback that improves learning gains. So if you'd like to use that as an example or any general problem that you approach.
Yes, indeed. So in the past, and basically for many years up till now, I have been focusing on the development of language skills. And more recently, I have started thinking about it in a more general, or from a more general perspective. So I already mentioned that my research with readability is about how we can make information accessible to different types of readers. But more generally, I'm interested in how we can make any type of information more accessible, in particular to people who are trying to learn something. So the most recent research concerns the development of educational applications, and in particular intelligent tutoring systems and application of these systems to teaching machine learning and data science itself. So it's the ITS itself is based on artificial intelligence and machine learning models, but it also is applied to teaching machine learning. So it's quite an ecosystem.
It's an exceptional idea.
Exactly. Yes. So, and when we started this started developing the system, it's called Korbit, the particular learning platform that we have developed. And the ITS provides the learners with video lectures. So that's yet another means of getting information. It's not from text, it's from visual aids, even though it's not sort of artificial intelligence automated. And then the ITS engages in a dialogue with the learner. And this is because it's been shown that asking people questions about the material and asking them to explain something actually provides better learning gains and leads to better learning outcomes, because if you want to understand something, try explaining this. So it's based on Socratic methods, where it's a very old idea. So basically, if you engage people in debates and in like arguments about the position, or for example, discussion on the content, it helps them understand the content better, and it helps them to really internalize it. So the intelligent tutoring system, Corby, works as this set of dialogues. So the tutor asks students questions, presents them with problem-solving exercises, and then they try to answer those. And if something goes wrong, for example, they haven't got the right answer, the ITS tries to sort of put them on the right track for the correct answer. It doesn't provide them with the right answer straight away. It rather provides them with the hints and explanations. So we have deployed natural language processing and machine learning techniques to generate those. And we show that indeed when we try to provide this interactivity on the platform, and also personalization, because those hints are selected based on what the student has said before and their learning profile. So we're trying to make it, as in, for example, one-on-one teaching, you would get this really personal approach about how to develop your skills in a particular subject. So that's what we are trying to replicate with the help of AI and machine learning. So we have experimented with that, and we present the results in this recent paper that you've just mentioned. And we do show that this leads to better outcomes. So students do learn better, but they also are more satisfied about the results. So they give better feedback about this approach.
Fascinating. For the audience, I'll have the paper, archive paper linked in the show notes. So please feel free to click on that and go through the paper if you'd like. I think it's really fascinating that you mentioned it's almost like a one-on-one tutoring. And I feel even I've just graduated last year, but even while going through college, I realized that it's still a process of learning how to learn. Active recall, spaced repetitions, all of these things aren't taught to us by default. And I had to actually go online and figure out, oh, interesting, these are also ways to improve. It's not that I'm just stupid and I'm not able to understand different things.
Now, that's exactly the good point, that quite often when we learn something new and we feel stuck, like, for example, something doesn't make sense, it might lead to this frustration and an idea that I must be stupid because I don't understand that. But I think the key problem here is that everyone, not everyone, perhaps individually, but generally speaking, there are lots of different types of learners, and we all approach the learning process differently. So for years, centuries perhaps, and this is not how people thought about it, this is just the consequence of the educational system. We can't provide everyone with one-on-one tutoring, but basically the educational system is based on one-fits-all idea. So we have one curriculum that should fit everyone, and everyone should go through it in the same way. I don't believe this is how it works. And I mean, that's not my idea. There are lots of people who don't believe that that's how it works, because everyone has their own journey, and everyone, especially in the fields of machine learning and data science, because it's such a vast field right now, and it's also a very attractive field because we know that these skills are applicable across many domains. People come from many different backgrounds, and that means when they come to this field, they come with also different skills. They already have some understanding of some subjects and some concepts, but they might also be lacking understanding of other concepts, and it's not the same for everyone. So the knowledge gaps are in different places, and that's why the personalizable intelligent tutoring systems and the approaches that can address these gaps and can basically make this journey very personal for each learner are very important. And that's what we can do as well, because we have now that everyone or many people are using online teaching resources and ITS, we can also learn from the interactions and learn from data about how to address the learning needs better. So that's where, for example, when you try to learn something new, you will not be presented with explanations that are beyond your current understanding. That's like the example with language that I gave. For example, if you start a new language and someone presents you with an article from The Guardian and you don't understand it because there are just too many words that you don't understand, that's not going to teach you anything. But if you're presented like piecewise with material that is appropriate for your level of understanding, but just one step forward every time, for example, just a bit more challenging. So you learn a bit more from, for instance, new words. Same with any subject. So it needs to be at your level of understanding, and then next step, a bit more challenging. And then when you get to the next step, then the next one, and so on. So that's the goal. How do we structure the educational process in the way that is personalizable for everyone and provides everyone with a better journey? And that's something that traditional classrooms cannot really address unless everyone can be provided with a personal tutor, which is very beneficial, but unfortunately not really realistically possible for everyone. But that's where ITS can actually do that for the learners.
That's almost fascinating and an interesting way to make it scalable. By default, it's not a scalable problem.
No, but that's where we use machine learning and data science really to learn from the data. That's where we can scale it because that's one of the major bottlenecks as well. Traditionally, education is provided by human experts, and we need this expertise, but we also need to be able to scale it up.
Absolutely.
Yeah.
And you draw a very nice parallel, which is how this can be similar to learning a new language, where you need to address, even for machine learning, people come with different backgrounds. Some like me skip math, and just start hacking around with frameworks. They don't know the basics. So you need to take care of those people as well. And they're all different backgrounds. So what does the end vision for you look like in a completed ITS world? How does the learner learn, and where does the human teacher come into the picture?
That's a great question. There is a research, if I'm not mistaken, from Carnegie Mellon University, where they show that ITS cannot do everything. And in particular, it's not that they cannot do everything, but for the learner, there is a clear advantage in having access to both an ITS and a human teacher. So there are certain aspects that are still for the teacher to decide. So my vision about that is not that we should replace everything with automation and AI tutors. A world in which humans will only be communicating with AI and never communicating with each other will actually be quite a sad one. So this particular direction of research with ITS, I see that more as help for everyone. So one example is the current situation with the pandemic. So necessarily it's not our natural choice. We are moving to online teaching and distance learning. So how can we leverage what we have with AI and automated educational applications to actually help this process? So it's just simply the situation in which personal tutoring and teaching might not be available. So that's one thing. But looking into the future, I think there will be a hybrid environment in which some aspects will be basically offloaded to AI. It may be teaching certain aspects of the course. Maybe it's more about the technical things. Maybe it's more about programming exercises, for instance, math and things like that. It's a big question whether, for instance, if we teach some other subjects like literature, history, or debating, or whatever else that actually involves interactions with humans, whether ITS will be a viable choice. I'm not saying they wouldn't, but I think that requires research and looking into that. It's also been shown that when students get stuck or frustrated and they get encouragement from an AI saying, "You're doing great," like continue, it actually matters less than when a teacher says that. So this is where human interaction is very important. So AI is not going to replace human teachers. I see that more as, can it help on both sides? actually on 3 sides or more. So school kids or students, parents, teachers, and potentially also industry in this domain as well. So it's more like, can we scale it up? Can we, for example, help teachers understand how to teach the students better based on identification of these knowledge gaps that we can get from the machine learning approaches to education? Can we generate some new material, for example, and doesn't have to go straight to the students? It can actually go to the teacher. He can say, approve some of that, but it basically would save a lot of time from human experts.
Again, it does sound fascinating. And I think to some extent, online courses are already doing this in the sense that the lectures are pre-recorded. They don't cater to everyone. Again, there's a prerequisite, assumed prerequisite. And then there's a forum or a community or different mentors or online TAs who try to help you navigate that. So I think we're already headed in that direction to a
Yes.
different extent.
So, yeah, exactly. It's called Massive Online Open Courses. And again, there's been research looking into that, and it shows that there are quite high dropout rates for
Yes.
this course. Lots of people start attending a course like that, but not too many people stick around. And when researchers looked into why that might be, this was exactly this concept or these aspects of teaching that are very important, but that cannot be addressed in MOOCs. It's about personalization. So it's, again, if you are watching a lecture and it just is pitched to a particular level, but it's not necessarily your level, then it will be hard to change anything about that. And if there is some misunderstanding about anything, it will be hard to change that, because the lecturer just made this video, but they wouldn't be able to explain this concept any better. And forums are helpful because you can ask that question perhaps on the forums, but it's again, it might or might not be addressed. And secondly, there is also no interactivity about that. There is no sort of guidance from the system. So that's what we are trying to actually address with the ITS. And again, it can be a combination of things. It can be linked to MOOCs, and it can help MOOCs to address those issues about personalization and interactivity that are lacking in MOOCs right now.
Another topic that I'd love to discuss is how do we expand this beyond English to other languages? I think that's the second step once we have this ready in English, because we were discussing this before we started the interview, that these are low resource languages. How do you think we can eventually start making materials or making models for low resource languages?
Yes, so languages where research hasn't developed as many resources or tools are called low resource languages, as you mentioned, and that's quite a big field and a challenging task in computational linguistics, because obviously we've spent so much time and effort on building tools for English at the cost often of other languages, because many researchers who would otherwise be working on other languages, they actually devoted their attention to English. We can use machine learning models themselves. We can try to transfer the knowledge that we have in English to other languages. We can try to, it presents very interesting challenges for machine learning itself. How do we learn something? Basically in few examples, like few shot learning. And how do we transfer the knowledge that we have from English to other languages? The main bottleneck with other languages is this fact that we don't really have enough resources, perhaps, or enough tools that will allow us to build more interesting systems around.
We don't have a ground truth, essentially.
In many cases, yes, but also the tools that are like the building blocks of more sophisticated systems. Like, for instance, to build an ITS for some language, right now we address in English, but to build it for another language would need to have these building blocks that lead to the development and building of a more complex system like that. So that's something that I think will be researched quite a lot in the future, and there is already a lot of interest and a lot of effort, and researchers are looking into how to address these problems because, of course, it provides a huge potential for development and research as well, and it's something very important to be working on.
Definitely. And going back to the bigger picture, like I was just trying to dive into different parts of the problem. Another one that you have been working on is assessing word complexity, which again comes into the pipeline for ITS, and also context awareness. So if you have any insights on these, how are these problems approached, and how do we understand? How can we rearrange words for different levels of learners, or rearrange concepts for different levels of learners?
Thank you. Great question. So when we think about the needs of different learners, it can be that people are challenged by different things at different steps of their development of the vocabulary, for example. And the people in the past looked into the challenges that people with different, for example, cognitive impairments face. And for some specific groups, it may be the complexity of the vocabulary itself. So it's indeed the longer, more complex words that they find challenging. For other types of readers, it may be the grammatical structures. So it's actually about longer sentences and more complex sentences that people like that, readers like that, would find challenging. So this requires looking into the particular issues for the specific, for example, if we are talking about development of language through different stages from beginner to advanced speakers of English, that requires similar research, looking into what exactly is challenging for speakers at different levels. For instance, in the very beginning, words that bear similarity with the words from our own language are helpful. Shorter words and more frequent words are helpful as well, because if we read something in another language, we see them more often, we learn about them.
So
at later stages, it's something different.
sorry to interrupt. So is this like to draw a parallel example? Is this like when you open up Netflix for the first time and you have to go through a basic questionnaire? Would this be like that calibration? So you, let's say in the vision, you open the ITS and now you have some few questions to calibrate the system?
Yes, exactly. So machine learning also provides vast opportunities for adaptation to the user and to the, in that particular case, to the reader. So that's where we try to change the system or the text along the way to make it as adaptable, as accessible as possible.
Okay.
So it's very serious, indeed.
For the audience, again, I'd like to mention your submission from, I think it was last year's NAACL, where you had the winning submission for complex word detection. I'm sorry, I don't remember the exact name of the work, but I'll have it in the show notes.
Yes, so shared tasks are competitions that are organized at ACL, for example, or similar conferences in computational linguistics and NLP. But it's very similar to Kaggle competitions, for instance, right? So that's where you have a task that's, and it's a level ground for everyone. So here's the task, and whoever wants to go with it, have a submission, can submit their system. And we developed the system that can identify complex words in text, and it's at this point didn't employ any sophisticated deep learning models, for instance. So it was simply based on these ideas about, it's a traditional machine learning pipeline and framework in which we look into different aspects of complex words, for instance, their length, their frequency, their other properties like what type of the word it is, part of speech, and so on and so forth. And we indeed achieved the best results, but since then we also looked into other aspects of what we can do better about that. And it's also So that's the first step. Their fields at this point was quite sort of young, or let's say this direction of research was quite young. But since then, we looked into various other aspects. For instance, an interesting finding for me recently was that the word bank, it's a classic example in computational linguistics because it has two different meanings. It can be a financial bank and it can be a bank of the river. And I think when I was learning English, I acquired the sense of bank of the river first because it was explicitly sort of taught. And I was a kid and perhaps I didn't think about financial banks. But apparently it's the financial bank meaning that is the simplest, the easiest to learn because we all call banks exactly the same way. Whichever country you come from, you would know about financial banks, but you will need to learn that bank of the river is called bank. So this is one example where just identifying that something as a word might be complex or not actually is also related to what this word means. And in different contexts, it will mean different things. So our next step was to address the context and to be able to say, in this particular context, this word is challenging, or in this particular context, it's not. So word meaning, context, longer expressions, as sometimes the word may be part of a longer phrase, like for instance, blue might not be very difficult to understand, it's just a color. But when we say out of the blue, or once in a blue moon, that's actually something different. So to be able to identify this type of problem is also quite important and challenging. And this is where, in fact, that's a good example for why it's challenging to do that in low resource languages. Because, for instance, there this step where we look at the different senses of the word is called word sense disambiguation. It's been worked on quite extensively in NLP in the past, but it's mostly addressed English. The step where we identify longer expressions is called multi-word expression detection. And again, it's been quite well researched in English, but maybe not as much in some other languages. At the same time, some approaches now, so say deep learning models, transformers, and other newer technologies, they help us alleviate some of these problems, perhaps, because if you have some data, you can probably address some of these problems without thinking too much about the constituents. But from the linguist point of view, it's still very interesting to actually understand what's happening and to research these other tasks as well.
I had found a lecture of yours in, I think it was a boot camp at Cambridge where you had brought the same example up, which was there was a relation between country and food, and the audience had almost guessed the wrong answer. I think it also depends on the data sets as well, depending on whatever data set is
Yes,
chosen.
that's a great example. It's not mine. It's from the paper by Thomas Mikolov and his colleagues, I think, at Google at the time. If I'm not mistaken, that's where they developed the Word2Vec system and introduced the embeddings. It's not that they introduced the concept, but definitely popularized it quite a lot. And now people are thinking about building the semantic models, helping machines understand language in terms of word embeddings. So that's basically, in plain terms, machine readable, machine understandable representation of a word meaning. Usually we are talking of a vector for the representation for the machine. And these vectors were based and learned from large data sets. And in this particular case, it really depends on what you provide the machine to learn from. Like, for instance, the more up-to-date models like GPT-3, they were built based on, say, the whole of the web. So it's like we have access to everything that was ever written in human language. Not necessarily, but sort of. And it really depends what you provide the machines with. It's a question of which type of data you learn from. So in this quite interesting example that I was given, they provided the machine with an example of a country and its typical foods. I actually don't quite remember which was the input one, but the answers were, for example, Japan sushi, which sort of would make sense to most people worldwide. Perhaps Japanese people will say that's not our characteristic foods. We would like to propose something else here. But a funny thing, I think, was that for the United States, it proposed pizza, for instance. And it's not something that you would think of as a human being, for instance, but that's just what comes from the data. So when you ask people the question, what's your association in terms of foods with this country? It can be anything, but it might not be pizza for the United States. So that's just what the machine extracted from the data. And the impressive thing here that I was trying to highlight in this talk is that the algorithm was not explained. So the association, the analogy was not explained in plain terms to the algorithm. The algorithm was not asked to search for the foods that describes the culture. It was just provided with the pairs of words. Japan sushi, what would you propose for the United States? And it comes back with the answer pizza, which might be not what we would say, but it's still very impressive that it finds it.
And this is also very personalized depending on whatever experiences someone would have. For example, I love chai, so I'd associate Cambridge or UK with tea, for example.
Yes, indeed. So that's a very good point, because when I say, for example, the machines can only be they can only be judged by what we feed them with. So it's impossible to expect from an algorithm to do better than what we provide it with, or to do better than humans, for instance. That's also, humans have been outperformed by the algorithms in some tasks, which is impressive, but in general terms, it's quite typical to say that we would expect from the machine to perform as good as humans. This is our upper bound. But for example, in this particular case, we say, well, this depends on what we provide the algorithm with. We've provided it with some news articles, and there, United States and pizza were mentioned alongside each other quite a lot, and the machine made this conclusion that those two are related. But you're exactly right. Actually, we are just the same. And that's why, for instance, as human beings, we just are exposed to all different sources of information, so to say, for free. We don't need, no one like specifically provides us with any inputs, apart from perhaps when we are children and our parents are sort of the source of language information for us, because we learn from their interactions. But in general, we just have access to all types of information, whereas for the machines, we still have to provide them with that. But if, for example, you're only exposed to news articles that mention USA and pizza, you will also learn this analogy, just like the algorithm in this case. So I think that might be not a fair point. In fact, we learn just like that too.
Just out of curiosity, have you looked at attentional-based models, or are you looking at these as well? Do you think they could be an interesting answer to this? Because they are somewhat related to this.
Which models?
Sorry, attention-based models. So
yeah, we have been working with attention-based models in a range of different tasks, and they are definitely very helpful, and they are definitely the step forward and an improvement on the previous models.
Okay. So zooming out a bit, I think there's also a really nice connect with Korbit.ai. So can you tell us your role there, and how does it connect with your research? Because I think both have a nice overlap.
Yes, indeed. So we founded Korbit. I'm one of the co-founders, and other co-founders, Yulian Serban and Sona Ching, they are based in Montreal. So at some points, we had this conversation that we would like to build something around dialogue-based education, and also personalizable and interactive education. So that's where the idea originated from. And now into our I guess, third or fourth year of existence, we have successfully built this tutoring system. We have over 10,000 learners registered and using the platform, and we are expanding the number of courses that we are teaching there. So originally it's machine learning and data science, and we are looking into further subjects as well. And I'm also a scientific officer in Korbit, which means we are constantly investigating the new approaches, the new challenging research tasks, because we have quite a relatively big team right now, over 20 people, and we have a machine learning team there, and we are constantly looking into how to improve what our tutoring system does with the advances from machine learning, NLP, and how we can make it also very interesting for the researchers that work with us there. We have collaborations with the universities. We have interns from the universities that come and work on projects with us. So it's all very vibrant and interesting environments for the researchers.
I'll have the website in the show notes for anyone who's interested in checking it out. Flipping your answer into a question. So you mentioned, how can we improve machine learning systems? How can we improve the human way of learning? I'm sure. So you also teach a few courses at university, and you're also leading Korbit. So what mistakes do we as learners make, or how can we improve our own learning process? For example, for machine learning, or even in general, anything you've noticed?
Yes, great question. I think it depends. It depends on the personality and the subject and so on and so forth. But I think a couple of teaching principles that I came up as a result of my experience in teaching students. First of all, try to make every example or any sort of new knowledge as interesting, as sort of accessible to you as possible. And I'm talking about perhaps self-learning, when someone takes a new material, new subjects, and tries to learn by themselves. But also in terms of teaching, for instance, the way I got introduced into programming when I was doing language primarily was by finding out that I can do exciting things about language using programming languages. So in the first instance, when I first encountered programming exercises in my life, I was not very taken by programming at all, because it was all about something that was not related to my experience and not related to my interests. So the very first advice, if, for example, you're interested in languages, the best way to learn about programming is to see how it's applied to language, and to see that you can do lots of amazing, interesting things, build your own applications with the use of programming languages, machine learning, AI, and so on. So I think it's a good motivational strategy as well. We can learn about lots of different things, but if that's actually not directly related to what we are interested in and what we are doing, it's much harder to keep ourselves motivated. So the very first thing is to apply this to something. And that leads to the second aspect, practice. So quite often for example, in classes, I may ask a student, so is it all clear? Do you understand that? And they might say, oh yeah, it's all clear. But then you ask them to do it in practice, or you ask them to explain it again, the Socratic tutoring methods. Okay, can you now explain it to you, for example, me or your peers? And that's where they might find out that, in fact, what they thought they understood is not really understood. So practice is the second most important. Well, I'm not ranging them by importance, but it's the second one that is an important aspect here. And thirdly, interaction. So this thing that you explain it to someone else is very important. That's why the individual tutoring systems work better, as in like one-on-one tutoring, for instance, or teaching in small groups. That's where you can actually have this interaction. That's where you can ask questions and answer them. So that's something that you can't do with MOOCs, for example, because when you're listening to something, you can't interact with that. And maybe one final thing is forgetting of knowledge. Like this expression, use it or lose it. So you might have learned something. If you don't practice with it, if you don't apply this to something specific, again, it's all related to these aspects that I mentioned, you will lose it. So I should admit, I was interested in Japanese and Chinese languages for quite some time. I tried learning them, but I don't use them. And that's how you lose language skills, for instance, right? So that's just my example. I try to learn a new language, but if I'm not using it all the time, either I need to practice it all the time through, for example, attending classes, or it won't be able to stick. And the same with any other knowledge as well. So I think being determined, motivated, and focused on learning something and understanding why you're learning this, how you're going to apply this, is very important.
I think spaced repetition and similar approaches are new, at least to me, and it's also it's not as linear as doing that for theoretical concepts, but of course that could also be one of the answers.
Yes, theoretical concepts. Perhaps we should make a difference between the practical skills and the theoretical, or applied skills and the theoretical skills. So trying to understand something from the theoretical point of view, gaining fundamental understanding of something, is obviously important, because that's knowledge that you can't lose. So once you understand it, it's a bit like perhaps learning to ride a bicycle, which is famously something that you can't lose.
Yeah.
So theoretical concepts, yes, I would obviously encourage people to look into theoretical fundamental science. Understanding the concepts is very important. But say if we're talking about really practical skills like language learning, data science, machine learning, for instance, trying to learn how to use a particular toolkit, it might not be something that you will be able to remember in a year if you haven't used it.
Another thing that I think at least I've struggled, and a few people I know struggle with, is coming up with a good project idea in order to practice these skills. So do you have any advice for us? Because some people like me, we get excited about NLP in general. For example, today I get interested in ITS, but then I don't have any idea of where to start or where to start applying these. So any suggestions for people like me?
Yes, of course. I think that's very important. That's probably, if we're thinking about should I start learning something or should I find a project, I'd suggest first find the project that you would like to work on. And once you have a goal, that's the problem that I'd like to solve, you will find out what are the methods to solve the problem and then learn about those methods. So that's the best way to really learn about a subject. In terms of NLP, if we think about it, almost everything in our life is expressed in terms of language. So whichever domain, whichever area you are thinking about, legal documents, financial stuff, medical, anything, it's all in language, text, speech, anything else. So in fact, to find a project in NLP might be easier than it seems, because you just think about, okay, what do I want to do? What's the project that really interests me? And then more often than not, you will find out that a lot of it is also related to language or expressed in a language form. So that's where you will need to use NLP methods. Often, perhaps to extract information, to extract something interesting about your particular task, but then you might also find out that other tasks will be useful as well. Perhaps it's summarization, extracting the essential content from something. Perhaps it's machine translation if you want to translate it from one language to another. And so we talked about low resource languages. So we have lots of tools for English, how do we address something in another language, and translation is one of those things that actually works across languages. Yeah, so basically there are lots of different projects, but I'm also happy to discuss any specific ideas if you have, like, you know, a starting point for what you're thinking about. And as I said, it's when I teach NLP to beginners, I usually ask them, have you ever come across NLP in your life? Do you think you're using anything that is NLP empowered? And first people might scratch their heads, but then when you give just the first example, it comes very easily that almost everything that we are using is actually related to NLP. It's predictive keyboards that we have on our phones, in our emails, it's machine translation, chatbots, Alexa, Siri, and other devices. It's spam filtering that we have, perhaps we don't see very often these days, exactly because it's been developed over such a long period of time, and so on and so forth. So lots of things that we are exposed with on everyday basis are really, they involve some NLP in them. And that's why it also brings another aspect that, for instance, if I try to enter some new fields for myself, I might feel like the barrier is high and I need some expert knowledge. I say, if you want to enter NLP, you are already an expert. Because if you build something, you get the results, it's easier to judge whether you are doing a good job with this application or not, because we're all experts in language. We understand what the results should be. So I'd say, good luck. Find your project in NLP and just look around. It's really almost anything you would be thinking about will involve some NLP, because it's just language is involved in everything.
That's a great advice. One thing I've learned, I am somewhat active in the FastAI community, and we had this long thread of language translations. One thing we learned was just taking the techniques that already exist and applying them to different corpuses or different languages already achieve state of the art, just because no one has done that already. So that can be also a low entry point for many people.
Yes, exactly. So there are things that people have looked into quite a lot, like, for example, building tools for English, which means that when you try to develop them for other languages, and if you're one of the first researchers, of course, you will do relatively well, because there is just nothing to compare to. But that also will open new opportunities for you. You will see that, okay, so I apply this, but that's where it works not that well yet. So that's what I do next. That's where I divert my attention next. That's what I do. So taking things, the tools out of the box, applying them to your problem, finding out whether it works or not and where it doesn't, is a very good starting point. That's, again, the scientific method as well. So when starting a new subject or a new task, first look what's done. So there's no point in reinventing the wheel. So some things might have been developed before, but in many areas in NLP, there is still a lot of potential. And for instance, low resource languages are providing researchers with a lot of grants for that. So that's really where people can do still a lot of things.
Definitely. Zooming out and coming back to the topic of research, I wanted to ask, and I read that you have been reviewing for different conferences in NLP, to mention a few: ACL, NAACL, EM, NLP. Again, I'm an outsider to research, so I was just curious if you've noticed any trends in NLP, or if you've enjoyed any trends in research through these years.
Right. So I think there is quite an interesting trend recently in NLP. So the field has been developing pretty fast over the past several years, and especially since we've got neural networks deploying models that can really work relatively fastly and can actually be built. So again, they've been around for decades. But the main problem was the resources enough data, enough compute power. But right now we can do that, and therefore everyone got into this race about how we can make better tools, better applications, but usually at the expense of more power and more data. So there is a lot of research into how we can build even more complex models with even more hidden layers or even more sophisticated algorithms. Eventually, it just means that we are sort of overcomputing everything, and we are also using a lot of resource where perhaps some sort of smarter approaches might reach similar results and might actually be better from the general point of view. So the recent trend now that is developing in NLP is so-called sustainable NLP, green NLP, and how we can build models that are just as good, but we don't need to train them for months, wasting lots of resource and compute power indeed. So it's a bit like brute force algorithms versus developing something that might work slightly like cheaper and smarter. So I think that's quite a good trend, because we need to step back and assess these new developments that we've done, and perhaps some of them might be achieved through more optimal approaches and algorithms.
That's a great insight. And I'll use this as a transition into the next question for people wondering how can we assess that you're actually writing a book titled "Getting Started with Natural Language Processing" with Manning Publications. So can you tell us more about the book? Who's it for? And it's in early access right now. What are you aiming to cover through the book?
Right, thank you very much. This is a good question, and basically the idea for this book was inspired by my teaching experience, and I have been teaching NLP to people from other various domains, like quite often it will be software engineers who would like to learn about NLP, machine learning, data science, and get into the field. And maybe people from various different domains, like, for example, lots of people from banking system, lots of people from financial, legal, and other directions of research, and other directions of business. And they come to learn about NLP. And so speaking about where the fields ended up right now, with lots of sophisticated and quite advanced algorithms, it sort of presents quite a high barrier from people who don't know much about NLP in the first place. So the way I approach that is to first introduce them to the fundamentals and the basic principles and building blocks within NLP. So I have been teaching a course on that for quite some time to people from various other domains. And based on this experience, I realized there is quite a gap here, because there are lots of, right now, for instance, there are lots of books and resources that are pitched at the higher level of understanding, speaking about how we can structure it better for the learners. So you wouldn't find it hard to find tutorials on how you apply deep learning, how you apply transformers to this thing or the other. But essentially, every new technology that comes along is not that new. At the core, it's always based on the principles, and all of these techniques, they have very long history. So I think it's much more important to, you mentioned learn how to learn before. I remember that. I thought that's a very good phrase and a very good point, that I think it's much more important to actually learn how to learn. And it's also more important to learn how to understand and identify those building blocks in any new developments. Basically understands where they are coming from and where the roots are. So before I started this book, I thought there is no introductory resource for people who want to enter the field, but they don't yet know how to do that. What are those fundamental principles and what are those building blocks? So the book is aimed at absolute beginners in NLP. The code is in Python, so Python is also a great language for anyone entering a new field, because it's quite interpretable and easy to understand. And there are lots of libraries that are built around Python, including deep learning libraries, but also NLP libraries around Python. They are abundant. So the book is aimed at anyone who would like to learn about NLP and basically doesn't have to have any prior experience, any prior knowledge about that. So it's all the way I'm trying to introduce that is in sort of as accessible and plain terms as possible for anyone to actually get into the field. And the aim of that is that once you have this introductory knowledge, you can go and explore further as much as you would like. So you will go and understand better any further material, including the most advanced and most recent developments in the fields as well. But the particular way this is introduced. So if you wanted to start from this advanced level, you might find it a bit hard to really sort of understand what's going on. That was my experience, and that was the take-home message from interacting with lots of new learners and lots of people with various backgrounds who come to learn about NLP. They just feel lost about where do I start? How do I make this first move? But believe me, once you've made this first move, you will just feel like, oh, there are so many different things that I can do and so many different things that I can build myself, which is basically just empowering people to do what they would like.
I think even though we have already the famous books that are there in NLP, those are very theoretical and very math heavy. And then the complete opposite side is very application based, somewhat lacking in theory. So what all topics are covered in the book? If you could just share those. So what can we expect to learn from it?
Right. So the book is also application-based in the sense that, as I explained before, I do think that the best way to learn is to immediately apply this to practice. But within NLP applications, there are applications that can highlight specific theoretical concepts better. Like, for instance, one of the early chapters in the book is about information extraction. And that's where you learn how to process the text. This is the first step, and this is very important. This is a building block in any further application as well, or almost all of them will be based on the idea that you can identify words in text. So it's not just a running sequence of symbols. Then how do we approach search? Do we search for the specific forms of the words, or do we search for something that is a bit more abstract, as in if you search for cars, you probably would also be interested to find out something about car as singular. So these aspects are explained through the chapter on information extraction. So while learning how to build an information extraction algorithm yourself, you also learn about the theoretical concepts in linguistics as well as NLP. So for instance, splitting text into words is called tokenization, and then identifying this core form of the words regardless of its particular form. Like, for example, saw, seen, and so on, all sort of boil down to see as the core form, right? And there are lots of those different forms that you can think about. For some other verbs, it might be even less transparent. So these techniques are called stemming and polymerization. They are also presented through these practical examples, because that's where I was coming from with the idea that everything is better put to practice. And then over the course of the book, we are looking into information extraction, then also into specific applications like, for example, spam filtering, sentiment analysis, named entity recognition later in the book, topic modeling, authorship identification. That's another topic through which you can learn about different features that can be used in any particular application around NLP. But that's an interesting aspect where you can identify the specific author of the piece of writing by investigating the differences in the writing styles, and how do you actually extract those in an automated way from the text. So each chapter introduces a theoretical concept that is based on what you've learned before, but also allows you to practice with a specific task. So hopefully after reading this book, you would be able to implement any of those applications yourself. You learn how to do that from scratch, but also, of course, you will be able to improve them through some other, for example, more recent advanced technologies, but you will understand them better once you have gone through the this fundamental presentation of the material.
And I think the last chapter, which is still to be written, ends on further guidance to NLP practitioners. And I'm sure I would have mentioned in the intro, Manning Publications would also be doing a giveaway for anyone who's interested in picking up the book. But this, my final question is usually a repeat question on the podcast. And every time I ask the same question, I get very different and insightful answers. So the question is, what's your best advice to someone who's just starting their journey in NLP or in machine learning?
Yes, great question. And I think it's related to what we've just discussed, how the field has moved and developed quite a lot in the recent years. I would say it's very important to sort of stay focused and to be able to handle this information, the overflow of information that is available right now. If, for example, you go on some of the scientific publication sites, like for instance Archive, you would get like dozens or hundreds of papers every day. So to actually be able to navigate in this sea of information, I think first of all, familiarizing yourself with the fundamentals, with the basic principles of how this works is very important. And then you will be able to navigate and to actually identify what is worth pursuing and what might be not that promising, where the different approaches come from, and so on. And what you mentioned earlier, learning how to learn, is very important. I think this is one of the most important skills right now because everything is changing very quickly in these domains. And it's not true anymore that you've done a degree in university and learned something, and then you will be able to use it throughout your lives. It's not like that anymore. So it's very important to just be prepared for all sorts of new information and be agile and be very sort of open for the new information as well, be able to and willing to learn new things, but to be able to identify what's worth sort of spending your time and paying your attention to. It's quite an important skill, I think. So it's something that I feel is comes with, first of all, understanding the fundamental basis of the subject, and secondly, with practice as well, of course. So try to get your hands on as many projects, as many practical assignments as possible. Try to apply this in practice, and then it will come with practice.
That's an amazing insight to end the interview on. Also, before we end the call, what are the best platforms for the audience to connect with you if they'd like to?
So I see that you have my LinkedIn profile open. I'd say this is the best channel to connect. And it also allows to get the personal conversations as well. So then if anyone would like to follow up with any discussions, we can do that on LinkedIn or figure out other means of communication. But that would be the best way.
Okay, I'll have it in the show notes as well for anyone who'd like to connect with you on LinkedIn. Katrina, thank you so much again for joining me on the podcast and for your time and for your amazing research.
Thank you very much. It was a very insightful and very interesting conversation for me, and a great pleasure.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.